Good morning, everyone. I am Satyam Tayal. I am pursuing research-based capstone project under Dr. Anil Singh sir, and my proposed topic of project is design of artificial intelligence-based voltage control oscillator. So let's start with the table of content, which includes a brief introduction, the literature review of some research papers and their findings, followed by the research gaps. After which we have the objectives of the project, a brief description of regression techniques, then the VCO model simulation, linear regression simulations and its results, followed by the Gantt chart, and then we have the references. So let's start with the introduction. We know that VCO or voltage control oscillator is simply an oscillator which can be controlled by input voltage or control voltage. As we know, the conventional oscillators were dependent on passive components like R, L, and C, and in order to alter the frequency of the system, we need to manually change the values of R, L, and C accordingly. However, in a VCO, the frequency can be easily controlled by input voltage, and we do not need to change the R, L, and C components. Uh, VCO primarily used as a local oscillator in the applications of RF applications. However, the design of VCOs with high range and linearity is a very tedious task, and also due to the variable VCO gain in the whole tuning range, it increases the difficulty even further as the noise sensitivity also increases with it. So let's now look at the literature review, which narrows down this difficult task of VCO designing. Zenrong and others proposed to change the size and the structure of the varactor resonator to compensate for the decreasing in the tuning sensitivity that are caused by the variation in capacitances. And also Gorbel and others proposed a novel technique to optimize VCO using current reuse technique. Also, a new parameter selection approach for high-speed ADCs using particle swarm optimization and SGD algorithms was proposed by Bansal and others. And yeah, from the literature review, it was found out that in order to optimize linearity of LC-VCO, there are many techniques, but they all have additional circuitry involved, which makes the designing of the VCO a little bit too complex. And there were very few designs which optimize the linearity without any additional circuitry. And it was also found out that VCO with high linearity and gain were desirable, and there were very few efforts towards AI based VCO designs. So now let's look at the objectives of our project, which includes the modeling of VCO using some desired software, which includes MATLAB or Simulink. And we have to develop and design the AI based technique model and its application for optimizing the VCO parameters for high linearity and maintaining a stable gain. Now let's look at the regression techniques. It is one of the most important and commonly used machine learning or artificial intelligence techniques. It is a statistical method that helps in determining the relationship between one variable and the other variables. There are different types of regression techniques, including the linear regression, polynomial regression, and there are several other regression techniques, including logistic and others. So let's look at the linear regression technique, which is used in this project. It is one of the most important regression techniques. It involves one or more independent variables that predicts the most accurate value of dependent variables, which is responsible in the linear relationship for between the variables. So in this figure, it can be seen that the predictive value is demonstrated in the red color for the data in blue color, where x and y have the linear relationships. So for getting familiar with the voltage control oscillator, I have designed a VCO model using 555 timer block, and it has been simulated in Simulink. So here is the Simulink model. As you can see, the 555 timer block has been used. So control voltage basically controls the output of the VCO, and it is provided to the cont terminal of the 555 timer. And if no voltage is given, then by default 2/3 times of the VCC is taken as its input, and this control voltage is responsible for controlling threshold and trigger voltages, and it also controls the output of the entire model. So now let's look at the simulation results. In this model, the outputs are observed by varying the control voltages, and in this case, we have varied the resistances of the R3 and R4, the R4 resistance basically. And after the varying of resistances, we have observed that On increasing the control voltage, the capacitor takes longer time to charge and discharge, and as a result of it, the frequency decreases. So now, in order to implement the artificial intelligence based algorithm to rectify the non-linearity and so maintain a stable gain of VCO, five-stage NAND gate based CMOS based VCO was chosen, and its voltage to frequency curve is shown as in the figure through the blue line. And as we can see that the curve is highly non-linear, and up to a certain point the increase in voltage can be seen to be resulting in the increase in frequency, and after that the any increase in voltage results in a decrease in frequency, which makes it non-linear. So in order to rectify this, linear regression technique has been used, and various type of libraries including NumPy, Pandas, Matplotlib were used for the implementation, which was in itself done in Python programming language. So here are the simulation results of the linear regression techniques. So for simulation of this work, data set of 1,21,622 inputs was recorded from the VCO. And from the output figure, we can clearly see that the original curve that is shown by the blue line here. So this is the original curve, and after the application of linear regression technique, it has been converted to the linear orange line that is shown here, and the output gain of this line is 71.804 hertz per microvolts. And in this case, the user has provided us the constant gain of 75 hertz per microvolt, and in order to maintain that constant gain, the frequency curve, the voltage to frequency curve was updated, and the new and the the latest curve is now demonstrated in the green line, which is linear and also has the desired constant gain as provided by the user. So this is the Gantt chart of this project, and we can see that the tasks like analysis of different VCO models, their techniques for optimized designs were studied and completed. Identification of artificial intelligence or machine learning technique to be applied in the VCO model has also been identified. Basic simulations were done and the results were studied, and finally the implementation of artificial intelligence technique in the VCO model has also been completed. So here are some references for the project. Thank you very much for hearing me.